EV technology is not very different than a lot of other forms of technology. The adoption rate is often dependent on the sentiment of the consumers. There's a lot of battery technologies, and the cheapest battery technology is going to be the winning technology. Lithium-ion batteries today are not cutting it because of two main issues. Number one, lithium-ion is at theoretical capacity. We cannot keep pushing the specific energy, meaning the energy per kilogram of the batteries further. And even if we do, then we are going to need to go way more in cost. The other aspect is the chemistry of these batteries. Today uses metals which are not widely abundant, like nickel and cobalt. They're not cheap either. And they have been sourced from places of conflict, and they have been mined with environmental concerns about the methods in which they are taken from the ground. So with that, we are not going to be able to satisfy the world's demand purely based on lithium-ion chemistries that exist today. We need to innovate. Lithium-sulfur batteries have the potential of exceeding the performance of lithium-ion today by almost 3 times. That means if it's in your cell phone, instead of charging it every day, you can charge it every 3 days. If it's in your car, instead of driving 300 miles, you can get almost 1,000 miles. In addition, lithium-sulfur batteries do not have any nickel, do not have any cobalt, do not have any limited supply chain metals. Sulfur is the 5th most abundant element on Earth. It is really cheap. If nickel is about $20 per kilogram and cobalt is about $30 per kilogram, then sulfur is actually about 10 to 15 cents per kilogram. So in that respect, we can imagine having a world in which lithium-sulfur could be the main driver for electric vehicles. Even though it's theoretically a great chemistry and the batteries perform great, if you were to assemble a lithium-sulfur battery, you would get a great first cycle. Your second cycle is not as great, and a third will start to decline steeply. By the time your battery has cycled 20 cycles, you're worse than lithium-ion. People have always known about this capability of lithium-sulfur, but never have been able to solve these issues of the rapid decline in the capacity of the batteries. The main challenge in the performance of lithium-sulfur batteries is that you have multiple steps in the discharge of lithium-sulfur, and one of the slowest steps is the formation of precipitate sulfides from soluble sulfides. Now, think of this as all of a sudden, as the battery is discharging, if the battery is a 5-lane highway, you're having lanes that are being closed as the battery is discharging. So we have identified the bottleneck in our reactions, and then we specifically went after that bottleneck reaction by designing the right catalyst to speed it up. Platinum itself was the most prolific of these catalysts. What platinum does is it steps in and tries to organize how this precipitation happens, preventing the formation of lane closure, allowing the traffic to keep going smoothly. Once we did that, we allowed the battery to operate at a much more stable performance, allowing it to cycle for hundreds of cycles. And now we are trying to take it to the next level, in which can we pack more energy in these batteries, can we keep the cycle life also in the hundreds or thousands of cycles. We today are expecting our electric vehicles to give us at least about 150,000 miles of lifetime. And we do not want to change these batteries 1 time and 3 times and 10 times. You just simply want to buy an electric vehicle in which the battery lasts the lifetime of the vehicle. So lithium-sulfur needs to advance significantly more for it to be able to meet that challenge. This discovery brings us closer to making lithium-sulfur battery commercially viable. It doubles the range of an electric vehicle, but this isn't just about electric vehicles. This could impact renewable energy storage, making the grid more efficient and sustainable.